And so our next talk, it's actually a panel discussion, and Ed, if you come down and the panelists could come up here, I'm going to introduce Ed. Most of you know Ed. He's the chief editor-in-chief of Semiconductor Engineering. What you may not know is he got his start doing crime and corruption, investigative reporting. But that was too boring, so he needed to come to a more dramatic industry with a lot more craziness going on. So he came here and never looked back, right?
Exactly.
So I'll let you get started.
Okay, as everybody probably knows, Jerry Frankel, SI2, Randy Smith, Sonics, Boyne, I always screw up your last name, so I'm not even going to try, at Agios, and
the Z.
Frank Schermeister from Cadence. So we can go on and on about the IoT and what it actually is, but in general, there are some standard components that we probably agree on, one of which is you've got sensors, you've got some sort of edge node processing, and you probably have some back-end cloud type of processing of all that data, depending upon some of it will be processed at the edge, some will be processed in the cloud. But all this running all the way across all of these is power. Power is a horizontal thing, just like security is becoming a horizontal thing in the connected to all the vertical applications that are existing in the IoT. How are we doing with power? Do we need more standards in order to address it more effectively? We certainly have UPF 1801.4. This has been, 10 years in the making at this point. We have some other ones that are coming up. Do we have enough, or are there too many already? Jerry, you're we're going to mix it up, but let's start down the row.
Well, I think we need more than we have, and that's why we have several efforts underway right now. 1801 was originally conceived as a power intent standard, not as a power modeling standard. Modeling, in this case, I'm using modeling to mean the estimation of power consumption. So 1801 has been extended to a certain extent for that, as we heard earlier from Suchma. 2415 and 2416 are working to fill the gaps. I think when we get 2415 and 2416 worked out and in production, I think we'll be in quite good shape. But we have work to do.
Randy?
I think we're still going to find we need to go a lot further. I think 10 years ago, I think some people had the right idea that power was going to, at some point, become a first-class problem. And that's where we are now. It wasn't where we were 10 years ago. We were more focused on functionality and making sure everything's going to work, and really still trying to learn how to deploy new verification methods, informal and things like that. Those were first-class problems. Power and security are becoming first-class problems now, where you can't get your product to market if you don't solve these kind of things. But the standards that we've developed, again, yes, we started with intent, we moved to modeling, we look at analysis. We really still haven't focused on design. We haven't really focused on some of the automation aspects, the creation aspects of what it means to build on-chip power domains and things like that. We're not there yet. We have a ways to go. Part of it is that our thinking is still rooted, and it's been pervasive through the discussions today, on the idea of software-controlled power management. And I think we're living in a world where that's the main thing today, and for some people it's hard to visualize something different. But 5 years or maybe a little bit more from now, that may no longer be the case. And that's the thing we have to get to realize, that when we're using software, we're burning tremendous amounts of energy to try and save energy, which doesn't make any sense. And if you move more and more of that in the hardware, and my way of thinking, this is not my original thought, but it's moving the power management more into the reptilian brain kind of stuff, where this stuff happens in the background because it's happening in the hardware, it's happening behind the scenes. The way we do it now is equivalent to me having to stop what I'm thinking about every second to remember to take a breath and tell my heart to keep beating. And that's just a ridiculous way to try and control the power of a chip. So waiting on a system clock to wake up to see if there's something to do, well, it now has to page in new pieces of memory to get the right driver code in to figure out if I can turn off a small little piece of my chip makes no sense. So I think we've gotten the standards today is the right start. We need intent to know what we're trying to do. We need to have better analysis tools. Unfortunately, on the system level side, the only two companies that try to do it have both been swallowed by Intel now. So, we have to come up with more for top level modeling and enable design. I think, for example, one of the things that's missing is protocols. So if we're building IP and we want each of our pieces of IP to have kind of a uniform way to change states, it'd be nice if we had a common protocol that we could use to tell them, go from state X.1 to X.3. And we don't have that today either.
Okay. Boyd?
Let's take just an example. IoT is really about these nice, mostly small devices which make our life easier. So imagine a startup who has a great, fantastic idea to change the world by combining a sensor, some smart logic, some Bluetooth or similar communication, and making that happen. Opening 1801 will not have helped it. So definitely, it's already a check for that first step. It's not software-centric enough. It's too detailed. It really deals with the tiny details of isolation and level shifters and so on. So it's the wrong stuff to open the book. Of course, once somebody starts putting transistors together and routing power supply lines and distributions, that's a different game. On top of that, 1801 doesn't have any clock information. It doesn't tell you what clock to turn on and off. So 1801 absolutely serves its purpose. It is good that it's made a step forward. It has this additions in two directions, SLP, as we heard this morning, these information, vision to have access to the 1801 through queries. But I agree with Jerry, we shouldn't overstretch it. What we really need to think is about what all these clever startups are thinking. How would they like to make these new IoT devices? Because this is where the innovation is and where the possible businesses. And I strongly believe, I agree with Randy, it has to have a software face. And without the software face, it will be very hard to deal with that. So that would be my point.
Okay. Frank? You've been really quiet down there.
Oh, you haven't asked me yet. So, but just out of curiosity, how many enemies I can make? We are about 30 people in here. Raise of hands, how many have been involved in standardization, given that this is an IEEE? Okay, including me, actually. So, so let's say it's about 20 people I can make enemies with here now by saying, if I look at your question, is there a need for new standards? I think my intuitive answer would be to avoid the question and say, standards are not in the way of things yet, for beyond the things we have. So I agree with Wayne, the activities ongoing in SI2, in IEEE, the things Agios is driving with the software phase, I agree with all that. But is the standardization in the way of those startups Wayne is referring to get stuff done? I would say probably not yet. And the reason why I'm saying this, looking at system level, for example, and SI2, the new modeling standards are great. But we have done these things by hand, so to speak, in products for the better part of a decade, if not longer, right? I think even when Wayne used to be my boss, we were annotating data into virtual platforms and so forth, and it has been done, and standardization has not been in the way of not doing it. What's then now the counterpart of the question is, would standardization accelerate it, right? So, and I think, especially in the software world, where you have a tendency today, when it comes to some of the things discussed in IEEE, when it comes to figuring out what are the different modes and how does the software switch through them, and how can I represent that to a software developer in a better way than device trees and so forth in the past. I think it takes the fear away that anything I do manually might be not useful next week, right? The challenge which is putting against it, a lot of companies are just doing it by throwing manpower at it, right? And so I don't think standardization is in the way. Can it help accelerate things? Especially on the software side, I would turn this all around into a positive. I think standardization could actually help accelerate it by taking the fear away. If I'm adopting this, it will be useless next week if somebody else does something slightly different.
You have a comment, I'm sure.
Yeah, I guess I agree that it is a function of having the standardization is going to impact how quickly we can adopt things. But we have to recognize when it comes to power, and if we look at how our customers are organized, we have two very diverse classes of customers. We have apps processors like Apple, Qualcomm, and Samsung, which may put 80 or more engineers on the power problem and can afford to do so based on the products they're building. And then the vast majority of the other designs have 1, 2, or 3 people. And if we can't, and they don't, frankly, they can't do it by brute force. They don't have the number of engineers available to them on the project to solve the problem by brute force. We have to come up with the standards that allows IP and EDA to build the automation they need to adopt new methods in order to solve their problems.
Well, which is the other way of saying what I ended on a positive note with, meaning standards can help accelerate things, especially for the people who don't have the brute force. Mm-hmm. So I agree with Rennie on it. But then again, looking at it from like trying to get my daughter through school and so forth, having to sell tools, has it been in the way of adopting anything to do with power? Not really. It has been really a question of where power sits in the hierarchy of needs. I mean, you had in the pre-discussions, we talked security and so forth as well, like where does it rank in the care-abouts, right? And then if it's in the top list, then it will be dealt with, going to Warren's point with the startups.
One of the things that I look at when I look at a lot of designs in the IoT is that, and you see it a lot with IP as well, is that it's not so much what's designed there, it's sometimes how it's used as well. So it may not just be this IP works with this IP and you know what you're going to get. It may be we're using phones in a different way or we're using devices in a different way, and the power characteristics are completely different on that. How do we get to that, to some sort of standardized way of doing it, or do we need a standardized way of doing it? We certainly need to deal with it more effectively. And anybody? Yeah.
I would say that the standards are really a reflection of how we do things today. And then when the working group comes together, they basically see similarities and have a prediction, because the working groups work, with have a variety of companies. At the end of the day, it is really also our outlook how things should be done in the future. We should not miss the point that, we would not have such a extraordinary workforce in software without languages which would have very clearly standardized how you write code. So you can communicate, you can exchange, and you can test in a better way. So this is great for functionality. We don't have that for power. Mm-hmm. So we don't know how good or how bad we are until we start communicating, because we make a product, we sell it, tell our boss, hey, this is the best one on the market, and yes, Apple can put 300 people, Samsung 250, and then a small startup or a company with a great idea which doesn't produce products which are going out in such huge volumes will have 2 or 3 people on that project. So ultimately, standards are, I would say, not a roadblock, but should be part of our, they are part of our education, definitely, and it should be part of our investment in the future. We at Agios, we intentionally embarked on standards because we said we would like to surf, but there are no waves. So let's make a wave and jump on that wave, and then everybody else will jump on that wave, and I think it's a great benefit if we kind of do it in a party and everybody's successful. The problem is essential in the fact that when we built computer science, not me, probably older colleagues than Mike, we didn't think about power at all. When we put the basic postulates of devices, architectures, languages, and so on. Power was a second thought. And in a certain way, through standards, we are now looking, hey, should you have done that a little bit different? And I think this is also a lot of reflections we see here on the hardware and software side, that the power and energy are having their revival now through every time through a new product line, through mobile, through IoT, and it will last forever. Because we are revisiting what we did good and we did bad in the beginnings when von Neumann architecture was put in place. Did this gentleman look at power? Did he, when MIPS defined instruction set? I think at the time around ARMS, RISC architecture, it became more and more of a power issue.
So I think Warren has a great point. It has, to me, and full disclosure, I've been in power optimization with some others here in the room back in like 2003, 2004. And I've been working closely with Warren here on looking at him from the cadence side and see what we can do together on the standardization side. I'm in big favor of power being a first-class citizen, so to speak, in the hierarchy of needs. To give a fun example, I was at a conference yesterday where somebody said, oh, in Maslow's hierarchy of needs, it really needs to be extended by two things in the bottom of being more essential. One being power, they were referring to the cell phone. And then underneath was before power is actually Wi-Fi. So, so to have the thing extended. So, but we laugh, but it's, to me, I was actually thinking yesterday about, oh, great, people are actually really concerned about power, right? And so it becomes a first-class citizen in the things, in the items we really need to look at, right? So that's why this whole notion we had a while, PPA, and one of the gentlemen I'm working with, Steve Carlson here, we're renaming this into PPT because power performance thermal is actually probably more important in some cases than the A for area. So that's actually the thing I find exciting, having been in it for a while, that power is really becoming a first-class citizen.
Well, that's pretty obvious with things like the Apple Watch, right? Because right now, if you have to plug it in every 2 days, it doesn't do what you want it to do. So
I know people who have two because they do one at a time.
they're in a different pay class than most of us.
Do
But
they synchronize if they have two? Do they
It's not that easy.
synchronize?
No.
any comments on this?
Yeah, I was going to add, sort of picking up on Voyan's theme. Some of the IoT stuff is, as many of the applications in our industry are, it's evolving. And so today, if you want to design some new IoT device and you're concerned about power, which you should be, there's only so many things you can do and so many techniques you can use and so many methods you can deploy to analyze, okay, what's my best architecture? What's my best protocol? And that's better than we could do a few years ago because we've learned, and we are still learning. To accelerate that learning and to move forward, we need these models because without them you can't compare. It's very difficult to compare accurately, say, this communication protocol versus that communication protocol. And yeah, we've learned along the way and we're building on that knowledge, but to really optimize this, we need better data, we need better models. And we're just not there yet.
Yeah.
So that's one of the things that I think these modeling developments that we're involved in will lead to more optimization opportunities and hence better optimized designs. It's not that people aren't trying today, they just cannot, due to resources or time or data, optimize as much as they would like.
Yeah, and to add to that, I agree, models are important, and the question becomes, what are you actually modeling, right? So you can model your device, and as Ed pointed out, for your iPhone, that's really important. In prep for this, I looked up like where the power actually goes, and I was very surprised that there are articles out there where actually claiming, oh, it's actually the cell network which is the power hog and not even the data center, right? So having the protocols being optimized for all this it becomes very important. And then even as you said at the beginning, with the 3 level of the edge node, the hub, my phone, and then the data center, modeling the scenario of what I'm actually trying to do becomes very important. And there's parallel standardization going on, right? I mean, there's intersection. We're doing models and we're doing software modeling for software in IEEE. And then on the verification side, we're doing this portable stimulus thing where we're essentially saying, hey, how do you actually model the scenario? So now that becomes a combination of standards where the scenario of a stimulus defining what I'm actually doing, I'm looking at something while I'm sending it, things like that scenario, how that then translates into how the enabling objects, the hardware and the software will behave and contribute to the power consumption. Then we can optimize across the whole spectrum.
Do you have a
Yeah,
comment?
just to add on what Frank's saying, we take it back again to IoT, which was our, part of our theme for today. That pain of power is at every place. If I'm an edge node, I should be, in many cases, we're power harvesting. Obviously, every bit of power I can squeeze out of it that I don't need, I can last that much longer. If I'm at a hub, interestingly, a lot of these, be they phones or even plugged-in devices, are now facing Energy Star ratings, both here in the US and Europe and things like that. We've actually come across companies who have come to us running for help because their modem had to run in less than 5 watts and it came out 5.5 and they can't produce a product for the next year and a half, right? So I mean, this happens, it's real. And then data centers, of course, we can't put a data center in Manhattan if you wanted to right now for any amount of money because they can't get you the power that you need for that because they consume way too much. So every one of these things.
We may have the space, but we're running out as well.
Yeah,
Dennis, you need to use a microphone.
Oh, is that an
I know
sounded
nobody
like the
wants
voice
to,
of God coming back.
nobody wants to miss your melodious voice.
I've got a reality check here, though. If we do everything right, if we get all the stuff together, how much more power can we save out of a device these days, in the future, than we are doing these days?
More than half of what we're using.
What's the assessment across the board here? What do you guys think?
You're asking for an absolute question. That's hard to predict. So, I mean, Randy was surprisingly fast. He may be prepared for the question. I don't know whether it's hard.
I've got a mic too, don't worry.
But the point I would make on this, we actually need to, given that we're engineers and we're sometimes getting lost in optimizing the noise, as opposed to physicists, as my high school and my university professor always told me. If I'm really here at the watch, the edge node device, the reason why I'm optimizing is lifetime of this or the length I can go between charges. If I look at it holistically, Maureen and I had these discussions in the past, and since I had this discussion with him, I've never ever watched a video anymore on my game console because he pointed me to documentation that's on the game console because it's all done in software. It's about 100 times more power inefficient than on a dedicated device like my TV decoder, like the Apple TV or the Roku or whatever your Poison is. So from a global power consumption perspective, that's actually the noise, even though very important because I need to deal with the thermal effects, I need to deal with the ability how long I can go between charges. In the grand scheme of things, even though it multiplies, things like using the right protocol to connect, and there was a great presentation Chris Rowan did on this a while ago, like the whole what wireless interface do you use, and then which decoder do you use, that's more important if I look at it holistically.
Yeah, I would. Sorry, go ahead, Jay.
Well, I was going to add a couple things. It's hard to answer with a rough number, but a half sounds good to me. And I'll give you a couple of examples that leads me to believe we could, do as well as that. First is if you go back to the chart that Chris Rowan showed, where it was the log chart where he had pretty much a straight line, starting with the NAND gate all the way up to some data center operation. So that's a very interesting chart. But from a systems designer and a product designer, one question is, what portion of that am I concerned about? So if I'm designing an IoT device, I'm not necessarily concerned about the power consumption in the data center.
That's right.
So I may divide my architecture in different points depending on what I want to hit. So if I want to do a really low power node, so I might do two things. One is I might do absolutely minimal processing there. Come up with a protocol so that I'm not shipping data, but I'm shipping symbols, and the data center can interpret the symbols and then do all the processing on that. Number two, if I'm doing minimal hardware, minimal operations on the node, I can maybe go to a really low voltage. Today, practically speaking, not many designs are done in near threshold voltages. It's just too hard. And it's also because the total amount of power, the performance you get drops off as you drop the voltage. It drops off rather dramatically. But the total energy consumption goes down even more so. So if I combine those two things, judicious partitioning of my system that allows me to do minimal local processing such that I can then do very low voltage design, I can go a lot lower.
So respectfully, may I challenge the question? Because if I look at my phone, just thinking about what you said, and the curve, since I have an iPhone, I've been charging it every day, like all generations. But since my first iPhone and now, it seems to have a similar power envelope of a day or a day and a half, something like this, or actually more like 10 hours, and then I have an external device to plug it in, which I take with me. But about a day. But it does so much more now than what it did 5 years ago, 6 years ago. So in terms of, the question is really, it's not power itself or energy itself, it's kind of the workload per power equation. And there we have improved much more than half, right? I mean, the phone seems to be, and I'm not an expert on that, I think the power envelope is only going slightly down or stays the same. But if I look into the amount of more stuff I can do with it, it's probably much more than half even in terms of, if I look at it from a workload per power perspective.
Well, playing off of what you're talking about there, though, which is that you get much more efficiency out of a piece of hardware that's designed for a specific function. Do a lot of the IoT devices now become very specific in what they're supposed to do, and does that change the design overall?
Oh yeah, absolutely. I mean, if I look into the example Voin brought to me at the time was game console versus Apple TV. In my case here, my first phone didn't seem to have the dedicated hardware decoder for the video in it. So I'm always afraid when I'm going out in the morning to the gym and I'm doing 45 minutes of cardio, will I get to a episode of my favorite show? And then I realize, oh, I've only used 10% of my power because they have made it a dedicated function which they optimized for that purpose, hardware and software together somehow, but really optimized for that scenario, right? So in that sense, yeah.
Boy, I think I sliced you off, sorry.
Yes. What we normally quote is that on mobile devices, just on the software side, you typically can squeeze out additional 40% efficiency more. And on the what we call plug-load devices, the devices like set-top boxes, TVs, gaming consoles, it's easy to reach 80%, 85% better design just by tuning the software perspective. Where are the limits on the hardware side? I also referred to Chris's slide, and he has shown the communication, power cost. He could have shown that for other dimensions. The key for me is asynchronous logic. It's something which is just built for a certain purpose. It only clocks but has to do a certain job. And here we are talking about orders of magnitude, because we can identify immediately how many transistors really don't have to clock. They don't have to do anything. They're just clocking because they're easier for us for them to clock. So what we are doing with clock gating and voltage gating and so on is simply mimicking the logic of asynchronous logic. And you can look at every, research book or every, introduction to digital design. You will see that there are synchronous clocks, synchronous logic, asynchronous logic, with a large benefit. If you simply don't clock things, they will not consume power. So order of magnitude easy, which means instead of 1 day, it's 10 days of using a phone, however, at the enormous cost of having to make the same enormous functionality with very different methods. And so we are playing with this, as we call it, software-defined power management, in between the ideal goal being the asynchronous behavior. So we are killing the clocks as much as we can, at the same time giving the user and the programmer, or most important, the designer, the impression that it's really a mainframe. This person is working on C, C++, libraries, and so on. And then we magically somehow start shutting things down, and the stuff still works.
Yeah.
I think, sometimes we get caught up in what happens in the application process. There's all these sophisticated techniques and stuff we're talking about. Our rather informal survey of a lot of the customers we talk to says they use 3 or less domains on most chips because it's just too hard right now to design and verify if they put in a lot more than that. And that's why we need all these new models and standards to build the tool set, tooling, design tools, analysis tools, verification tools to make all that much easier than it is. They're not doing it now. Yes, they do it on the phones where they got the volume for it, but the vast majority of them have 3 or less domains that they control. And at the same time, we're seeing these new designs, and again, different chart of Chris, 120 or more blocks. There's a lot of opportunity to control more granularly power, but they're finding it too complex with what we've given them today in terms of IP models and tools. And that is our challenge to solve, to allow them to really bring down the power.
One of the hidden taxes in all this connectivity which the IoT brings is security. And security costs power. It costs energy, it costs power, it costs cycles somewhere. How do we build that in, and how do we take that into account? And is there a better way of doing it than what we've been doing now, which is almost nothing?
I would say that security is very often an excuse for not doing a good design. We have seen cases where people simply don't want to put additional efforts to properly sleep their device, like set-top box. And then when they are forced, either by the manufacturer of these devices or occasionally by the regulators who don't like to see 200 watts 24/7 being burned in your home, then most of them give up and say, okay, let's take the mobile processor, fine. Let's take a more efficient memory. Let's go for even, green disk drives, which if in the case of set-top box. But if you touch them on security and say, oh, we need to constantly be in charge of the unit. And then for us, the example is, take a look at the phone. It's not all the time in charge, meaning the main processor is not all the time crunching data. So it's still, you're keeping quite a good security on an asset which has a lot of value for everybody. So I think it's also the perception of that security is very important. We agree all on it, but there are better ways. For example, having hardware accelerators like what Chris was mentioning here on IES and similar protocols to engage with the dedicated hardware on that.
Yeah. Randy?
Yeah, I think we had to break down security in at least 2 major categories. There's active and there's kind of the designed in, which I'll call passive. So active means things like encryption and other techniques like that. That's more function, it's going to take more power, and I have to account for that. However, back to what Boyan's saying, you can design in better stuff. In the case of our business being in on-chip networks, you can design hardware firewalls that don't cost anything. Right? You can literally set up your router so that this block can't talk to this block, like your fingerprint recognition can never get a message directly out to your radio, so you won't be able to, rogue software won't be able to transmit your fingerprint someplace. I mean, that's just a simple thing you can do in design. It's still security, but it does mean extra effort in design to make sure that you stop the things you don't want to happen from ever happening. And then those that you have in a more general purpose system, you have to say, I'm going to pay the cost of having encryption and having other forms of security that I'm going to have to enforce. So I think, yeah, there's going to be some cost, but we can be smart about it, and there's other ways to get things done so we don't have to pay more than necessary.
Yeah, I was just going to add that on the encryption side, there will be some more costs, but I don't think it'll be that high. If we can have and I hate to beat the drum on this, but a standard for encryption for the IoT, then that can be built as a piece of hard IP. It becomes small, it becomes power efficient, and yeah, it'll consume some power, but if it's hard IP, I think it can be made quite power efficient, and it's something people can put in, kind of almost as a no-brainer. But we do need the, standard protocols with standard security in those protocols to enable people to define what is that encryption, what does that security processor look like.
So there's oh, go ahead.
We got a mic. Dennis, here's your mic.
Mic is coming.
Your mic is coming.
Your mic's on.
Anticipated this.
Believe it or not. All right, here you need some power.
Voink, no, I don't need any more power. It was interesting to take the power out of the encryption of the security chip, but that's the actual thing they use to hide what's going on. Because people will take, oh, you were, oh, sorry, I'll stop then.
No,
You
go
go,
ahead.
Frank. So, I mean, power is almost it's an enemy and it's your friend at the same time.
Yeah, so I
Frank, you have
literally,
the
I
last-
had
the last word
had
here.
that on my mind because the whole power is. I was at Embedded World in a where he used the power profiles to basically hack into the encryption and so forth. So it's quite interesting. But then at the end of the day, going back to the needs, it depends on the design, right? I mean, if the requirements at the end dictate that security is more important than power consumption or lifetime of the battery, well, then we'll have to do it. And there are a lot of devices where I want that, right? I don't want my calorie consumption to be directly transmitted to healthcare and so, or somebody to hack into it and so forth. So, and the pacemaker, like exactly. So those are, I think it's a question of what type of device you're looking at that the power really becomes, security becomes a higher concern.
Okay, Stan's about to beat on me, so I'm going to end this panel, and thank you
my
all very
job.
much. Thank you all.
I thought we have 10 more minutes.